Hey there, welcome to NGSS Physics. So we are going to be talking about power today. If you are, one of those people who like to reference some items, you can take a look at the power sections in 4.3 of your online book. Okay, let's get started. Hopefully you have something to write with and you've got a calculator ready to go. All right, so previously we talked a little bit about work, and work has a very, very specific meaning. If you recall, it's really represents a measurable change in placement of an object caused by some external force. Okay, so in other words, let's say you're pushing on a brick wall, but the wall doesn't move. Even though you're applying a force, you're not doing any work at all. But if you do get the wall to move even a little bit, then you have done some work, because it's not just the force, but it's actually the distance that you have moved the object. So it's a very, very specific meaning. Power then comes from work, actually. Power is the rate at which we do work or use energy. Recall, work had the same exact units as energy, the joule. Okay, so if we then put power into a formula with the rate, okay, notice that we have a time factor involved. How much work are we doing per unit time means that our formula is going to look a little bit like this. Power is equal to the work over time. And if work is force times distance, then we can also say it's the force times distance over time. What does this do for our units? Well, if work is in joules and time is in seconds, the units are a joule second. Those are the units for power. It just so happens that we rename the units a watt. 1 joule second is equal to 1 watt. And maybe you're used to that unit for power, the watts. If you look at the back of any of your electronic devices, you'll see how many watts that they use. And that is energy per unit time. All right, let's take a look at power. Power is basically simply an energy exchange per unit time, like we said. Horsepower is actually equivalent to 745 watts. Take a look at this guy going up the stairs. Okay, we can actually calculate how much energy per unit time he's using. Let's say you're walking up the stairs and your weight is 70 kilograms or 700 newtons. Okay, and you go up 3 meters. Okay, that means that you're doing 2,100 joules of work. And let's say it takes only 3 seconds. Well, that is equivalent to a 700 watt output. Let's take a look at some sample problems. Okay. A 5-kilogram cart is pushed by a 3 Newton force against a friction for a distance of 10 meters in 5 seconds. Determine the power. First step, calculate how much work is done. Work is the force times the distance. That's the first step. So my force is 30 newtons and my distance is 10 meters, which means that I have to do 300 joules of work. Now, calculate the power, which is work divided by time. So since we have our work, all we need now is our amount of time in seconds, and we plug those numbers in, just like this, and we have 300 divided by 5. That's a simple calculation. It tells me I am going to do 60 joule seconds. That's the rate that I am going to be doing that work, or 60 watts. Here are a couple of more questions. A machine does 30 joules of work in 10 seconds. How much power is that? Well, power is equal to work over time. And it looks like I have work here. Looks like I have time there. Okay, 30 divided by 10. And you can see that you're going to get a certain amount of watts. You go ahead and calculate it. Question number 3. A 50 Newton bucket. Newtons tells me that this is a force. Okay. This tells me this is a distance. And seconds tells me this is a time. So the first step here will be figuring out your work, which is force times distance. After you get your work, then you can figure out your power, which is work divided by time. So first off, you've got to find out your work, and then you can find out your work per unit time to get your power. Let's take a look at the solutions. Okay, in summary, power is how fast work is being done. It can be quantified using this formula, work divided by time. The units for power is the joule second, or the watt. Thank you for listening. We'll see you back in the regular